Good day, folks. What we're going to do here today is we're going to build a little project. Now, from time to time, you're going to need, in electronics, you're going to need to deal with precision resistor values. You can buy precision decade resistor boxes, but they can be very expensive. They can be into the thousands of dollars to get really good ones. And if you're only using them once in a while, that's not great value for money. So what we're going to build here is a precision substitution resistor, and we're going to do it using these wire-wired resistors, which I got on Fleabay. And this one here is 100K. It's a 2-watt resistor. It's a 10 turn. This one here is a 1K. It's a 1-watt resistor, and it's 5 turn. And here's a 100 ohm resistor. It's also 5 turn, and it is another 1-watt resistor. And I also got, same place I got, and I'll put the name of the vendor in the description below. I also got these multi-turn knobs as well to go along with them. Now the box I had before, I had built an amplifier in it at one time, and I'm just going to reuse that. I just drilled a few extra holes in it for what I need here and resized a couple other holes. I got these binding posts from another item that I pulled apart, so these are costing me nothing either. And I saved wire, so I'm going to use this saved wire from some other project. All totaled, I mean, except for the wire, you can buy all these parts on eBay for about $17. So this is going to be very cost effective for when you need a precision resistor value. And you only need it once in a while, so it'd be a handy tool for that. So, one of the things that you need to be careful about in putting this thing together is getting the resistors mounted into the box the right way, so that the knob and the resistor, so you need the resistor to be facing this way so you can wire it, but you need the knob to be facing in such a way that the window is pointing in the direction that you want it. So that these have a little relocating pin that goes into this ring here, and you want that kind of located up there like that, or whatever your preference is. And then you need to tighten that down. But even in doing so, they can move around a little bit, as you can see. So the idea is to make sure, check it out, check it, and make sure it's in the right place. And then tighten it down bit by bit until you get the results that you want. Now, one of the things I like to do with the binding posts is to make sure that the holes in them, as you can see there, those holes that wires go through, if you can see that, I like them lined up in a way that I know where they are, so that you know, whether you like them straight up and down or side to side. I like them side to side, but I like to know that they are there. So what I'll do is I'll put something like this little Allen key here. I'll put that through there, tighten it down just a bit, keep them stable while I tighten them up. And that'll ensure that my holes are lined up in a way that I can predict. Yeah, for putting these knobs on, you also want to make sure that put the resistors down to their minimum value. Then set the knob to 0. So 0, 0 like that. place it on here and tighten it up with the Allen key. Okay, got my iron turned on and heating up. And so what I'm going to do is going to wire from the bottom tab to the top tab of each of these pots, and then from the bottom tab of this one to this terminal, from the top tab of this one to this terminal, and that'll complete our circuit for us. Well, there's the wiring is all done. Very simple to do. So far this project has been taking about 20 minutes, so not a heck of a lot of time involved. So let's just pop the case on it and we'll give it a try. Now I should mention that the 10 turn pot gives us a 36 degree per K ohm. This 5 turn 1K pot here gives us 180 degrees of movement per 100 ohms. And the 100 ohm pot gives us 18 degrees for a single ohm. Now I do not expect this thing to have absolutely 0 ohms, and it's probably not the best arrangement for very, very low ohm resistors. But for resistors several hundred ohms and higher, this should provide very good precision. So let's give it a little test here. A couple of banana cables. And turn it to ohms. So it looks like the lowest ohm that we're reading we can get is 1.6 or 1.7 ohms. That's okay. I'm sure that these things don't go down to exactly go down to 0, and there may be some resistance along the way in the cabling. But let's see what we can do as far as getting a precise value. So let's try something like 10,000 250 ohms. There we go, 10,250 ohms. You want 10,251, 10,251. Any value you want between 100 and 1,100 ohms. I believe that's around about what this will go up to. But we should be able to go anywhere from the approximately 2 ohms up to this value in 1 ohm increments. This way you don't have to keep a huge number of high precision resistors in stock, because those things are expensive. Like a single 0.1% or 0.3% resistor is going to cost you about $17. So if you need those resistors and you need to find out what exact value you need, a little device like this can help you pinpoint what you need at a very, very low cost, and then you buy only the resistors that you need for your project. So that's it. Thanks for watching. Have a great day.